My name's Tony Alcocer, and we're going to be talking about rockets and stuff. And this is for the Small Satellites for Secondary Students program, where they're building the payload bays, or payloads actually. And so this is one of the payloads that you guys should be working on currently. And we're going to talk about how to get this into a rocket that you guys are going to be making and then be flying it, hopefully. So first we're going to talk a little bit about the program, in that it's funded by NASA and it's put on by Sonoma State University with a little bit of help from AeroPac. And I'm one of the AeroPac members that was down at Palmdale helping teach your instructors. So while I was down there, I realized that it was a lot of stuff was about the payloads themselves. And since I'm a rocket guy, I wanted to get as much rocketry into the program as possible. So while I was down there, I had a RockSim program, which is like a program to design rockets, and I think you guys have that program. So I designed a rocket to carry this payload up to about 900 feet. When we talk about rockets, there's two different classifications for rockets. There's model rockets, and then there's high power rockets. And a model rocket, maybe you've already flown some or seen them, are usually pretty small, and they maybe go 1,500 feet at the most. The legal definition is that it weighs less than 3.3 pounds and it has less than 4.5 ounces of propellant in it, I believe. And so how I kind of got involved in rockets is I did them as a kid. When my kids got older, I did them with them. And then currently my granddaughters are of age, and I'll be making some rockets with them. Well, if we look at this rocket, and it's a model rocket, it takes some notification of airports and landowner permission. But once you move from a model rocket that's 3.3 pounds up to a high power rocket, there's a whole bunch more regulations that you have to deal with, including airports, local authorities, and permits and stuff. And so when I designed the rocket to carry this payload, I wanted to design one that was a model rocket. Well, if we look at this rocket here and how big the payload is, you can see that there's quite a challenge to get a rocket capable to do that. And so first we'll talk a little bit about what the parts of the rocket are and stuff, and how they have to weigh or balance, and motors and stuff, and then I'll show you what we came up with for the rocket design and stuff. So basically a rocket is fins, a body, and a nose cone. And how these hobby rockets work is that a motor would go in the bottom of this one, and this motor would be about the size of my finger, and I believe it would be a B motor. We set it on a launch rail, which is a rod. We ignite it electrically, and it goes up. And as that motor goes up, there's a delay element in there that is burning when it starts at ignition. Once it gets to a set time, and in this case I think it's a 5-second, that a charge in the top of the motor would go off, and what it does is it blows off the nose cone, which eventually pulls the parachute out, and then it falls back to Earth. And motors are classified or rated by letters. So an A motor would be about the size of my pinky. A B motor, ring finger. This one happens to be a D size motor. And so legally, for a model rocket, we can fly up to a G motor. And so the motor that we're going to be putting in the rocket you guys are going to be building is called a G80. And how the motors work is they double in power for every letter. So a B is twice as powerful as a C, a D is twice as powerful as a C, and so on. And so how high do these numbers get in high power rocketry? They go all the way up to Q. And so we can see this motor here that it has a nozzle about this big in it. And then if we go to composites, because this motor here is black powder, that this motor here would be much more powerful than the black powder because it's got modern technology in it. This motor here is up to a G, which is similar in size to this one. And so they just keep going up and up. This would be an H. This would be a J. This one would be a K. And this one is an M. And so you can see that as we get more power into them, the motors themselves get bigger in diameter and they get longer too. If we hear a big crash, that's just all my parts falling around. So that's the motors, and they have delay elements in it. And so the delay that we're looking for in our G80 motor, the delay we're looking for our G80 motor would be a 7-second delay. That from the time it lights, 7 seconds later it's going to reach apogee, which is the highest point of its flight, and then we want that charge to go off so that it makes those hot gases blow the nose cone off, and then the parachute comes out and it brings it down nice and slow. So the fins give it stabilization. The rod does until it leaves the rod. It has to be traveling at least 30 miles an hour when it leaves the rod so that we have enough air blowing by so that the fins are actually working. The 2 points that are critical when we design or when we fly a rocket are called the center of pressure, which is, if we look at these fins here, that if we did a cardboard cutout, where would be the center of like a weather vane and stuff? And it would probably be right about here, and that's called the center of pressure. The other point we need to take into account is a point that is called center of gravity, that where's this rocket balance at? And then the center of gravity must be ahead towards the tip of the nose cone from the center of pressure. Otherwise the rocket doesn't fly straight. So we'll talk more about that when we build the rocket, and then the last segment we're going to talk about launching and how to put the payload and stuff in there. So the first problem I had designing this rocket is getting the payload bay in there. And keeping everything under the 3.3 pounds. So this is called lock or craft tubing. It's made for model rockets. You can see it's just much bigger, and that the payload you guys are working on will actually fit into it. Except for that way. And so what we have to do when we put this in the rocket, and I'll show you how to modify the antenna attachment to get it to fit into the rocket that you guys are going to be building. So now we know what size the rocket's going to be, we have to figure out where to put this. And in most rockets, there's not enough room in them, because when we do it as a hobby, we're either putting video cameras or just much bigger motors in the things that we fly. And so this is one I built a few years ago, and you look at this and it's like, well, look how much room's in this one. This one happens to be carbon fiber. I did it all myself with cloth and epoxy and designed the nose cone. Well, there's hardly any room in here at all. The parachute is in there, so that's taken up. This part I'm about to not twist off goes to right about here, and this is where the electronics are. Once you get into high power rocketry, we're not relying on the charge on the motor to make everything happen. We have electronics in here, and so this is the electronics. It gets hooked up to a 9-volt battery. And it senses liftoff, it senses the barometric pressure, acceleration, and I can set it to do various things either on the way up, start other motors, or things on the way down. And so in this rocket here, this is my electronics bay. and that's where all my electronics. Once you get up to about 10,000 feet and stuff, it's really hard to see these rockets, and so trying to find them is going to be hard too. So I have tracking stuff in here, whether it's GPS or a radio tracker. This space is totally taken up. This motor that's in here right now goes up almost to the tip here. Well, that last few inches that are in here is taken up by another shock cord. And so you can see that I have no extra room in here. It's basically motor, electronics, recovery, transmitters, and a parachute. And so for us to fly your payloads, it takes a special kind of rocket that usually we don't have because we're putting cameras or bigger motors and such in them. And so for the design of your rocket, we started out with this being the primary purpose of the rocket, is that we wanted this to be the primary thing. The rocket is going to be the workhorse, and this is actually the job it's to do is to get this up about 900 feet. And so the nose cone is a 3-inch nose cone, and it fits onto the tubing very nicely. And most of the nose cones have a plastic bottom on them. So what I did is cut that off, because otherwise that would all be dead space. And I'm making it so that the antenna will go up in there. And then we have a coupler that will bolt to this, etc., etc. And this is the prototype. So right now I'm going to just take the antenna off. I'll show you how to relocate it here in a little bit. But in the kit you'll get stuff. Avalanche. In the kit you'll get a rail to mount this on. So that gets mounted there. And we'll go over this at the end of the video. The battery and stuff gets taped on there. You get a little plug of foam that goes in the bottom here. So it's all bolted together. Right now we're just going to sit this in here. And then we have 3 screws where this all gets screwed together, and then our parachute gets attached to that. So this is our payload bay. And then the rest of the rocket, which I didn't bring over, fits onto there, and it has your parachute and a baffle which takes some of the heat out of the black powder so it doesn't burn your parachute. We'll talk about that during the construction, the fins and the motor. So that's this is just kind of the introductory of what we're going to be doing. The construction plans are going to be by video. The next video will be us building the actual payload and the rocket and stuff. So after today's video, there'll probably be 3, if not 4 more. And you'll watch me construct the rocket. The kits come with the glue, the parachute, all the screws that you need, sandpaper, and all the parts to make the rocket. So right now what we're going to do is we're going to get back to the payload, because I have to return the payload to Sonoma State tomorrow. So this is kind of out of sequence, and we're just going to put this together. So for right now we're just going to take these screws out. Should be only finger tight. That one's not. We're going to take the nut loose from the antenna. We're just going to loosen it up. And I'll take pictures of this because the next step is very small and stuff. We're going to take a little piece of fiberglass and we're going to use that as a mount, because how the antenna mount into the Wi-Fi is kind of delicate and wants to pop out. So we're going to use that little piece of plastic that I had there. we're going to take a tie strap. We're going to put this through, and I'll take a picture. Once it's done, you'll be able to figure out what it is. So I'm probably going to stop the video because I'm going to start shaking and this little piece falls out quite easily, and then we'll start it back up as soon as I get this all done. So I actually got it much faster than I thought I was going to. So what I've done is I put the little piece of plastic right under where the antenna comes out of the Wi-Fi antenna connection, put the blue zip tie around it, and tightened it up. And so what that does is it helps anchor that antenna connection. So once we get that done, cut the end off the zip tie, finish taking the other end of the antenna out. We're going to put the antenna back on. We're going to take our other zip tie. And this is the hole that the antenna came out. And then this is another hole that we're going to use. So we're going to put it in the antenna hole. And in the mounting hole. We're going to lay the brass part of the antenna in there. Close up our zip tie. And pull it nice and snug. We're going to cut the end of that off. And we're going to keep the little gold washer and the nut so we don't lose it. So now we have the brace under the antenna. We've relocated the main antenna itself. So we're going to take this mount here, there's two holes in here. Put the screws back in. The forward hole. The reason we're doing this is we don't want this rattling around in the payload. Even though this is a model rocket, it's still going to be going 150 miles an hour. And it's going to be pulling, I think, 5 Gs. Means that this whole thing's going to weigh 5 times its normal weight. Going to take a rubber band, and we're going to rubber band the antenna to the mount that we just put on here. Just around a whole bunch of times, twisting it, etc. It just keeps the tip from rolling around in there. So we're going to take our battery and our battery connector with some black or any electrical tape. We're going to make our connection. We're going to take the black tape and we're going to tape that connection. We're going to push it down and we're going to go around it a couple of different times. So then I'm going to take this and I want the lead coming off towards the payload. So I'm going to come back around like this, and what I'm going to do is I'm going to tape it right to this mount that we put on here. Because the first 1 or 2 wraps is kind of tricky. Once we get around there, then we can tighten it up somewhat. So we have our battery mounted on there. We would then get ready to launch it and stuff and plug it in, but in this case here we're just going to take it and put it up alongside here because I don't want it to turn on right now. So we're going to stick this inside. I'm not going to force anything. I'm going to take the piece of foam rubber, put it down in here. And then we're going to slide this on. I have some alignment marks here so that my screw holes can line up, which are right there. So there's going to be a little play on that. That's this foam rubber doing its job. We're going to take the 3 screws. Again, the only reason I'm doing this is because I have to take this back tomorrow. Put in all 3 screws. Tighten them up. Once you get there, we're not going to tighten them up. And then the biggest thing is making sure that this is hooked to the parachute. So now our payload's in there. It's not rattling around. It's very secure. So I went and got the payload. Yours is going to be a little bit different. This one is actually too heavy to be classified as a model rocket. So inside the body tube here is we have a 60-inch parachute. We have about 20 feet of recovery cord. We're going to put the parachute back in here. And again, the last video we'll actually go out and be launching the one that I build. So this is a quick connect. We're just going to screw it down. Then it's ready to go. So then once we have the payload in there, we take the motor goes in the back here. There's going to be a washer and a screw to hold that in place. Igniters and stuff, and I'll go all through that at the last video and stuff. And before I launch it, I want to make sure that my center of gravity is right. And so on this rocket here, I have my center of pressure marked, and I have my center of gravity. And so if it doesn't balance, at least to that point right there, if it's back here somewhere, I'm not going to fly this because it will not fly. It'll be unsafe. And so I want to make sure that it's going to balance in the right place, and it does. And so that's your payload. This is the S4 rocket. So if your teachers or instructors have any questions, they can get a hold of me through Sonoma State. I think I'm on an email list with them. If there's any questions, and if you don't understand something that I just showed you, have one of your friends watch it with you. Maybe they have a different view on it. But if nobody can figure out what I'm talking about, have your instructor or your teacher email me and ask me the questions that you have. Okay? Thank you.